Now we are going to discuss how to find sum of a geometric progression. Geometric progression. Yeah. Here there are two formulas. Okay. There are two formulas. We have to categorize this according to the R value. Okay. R value. It's very easy. Okay. If the R is less than 1. Okay. If the R value, that means the common ratio is less than 1, we have to use this formula Sn equals to A into 1 minus R to the power of n upon 1 minus R. 1 minus R. This is the formula we have to use to find our sum. Okay, we will do some examples, so don't worry about it. If the R is less than 1, this is the formula we have to use. So then the R is greater than 1. If the R is greater than 1, Sn equals to A into R to the power of n minus 1 R minus 1. Okay. Yeah, there is a relationship. You can see the relationship clearly here. If the R is less than 1, okay, if the R is less than 1, we can subtract from 1, we can subtract that particular value. From the 1, we can subtract that particular value. So, we will receive a positive value. Okay. Here you can see R is greater than 1. No? So, here the R power of n that come before the 1. From that we can subtract the 1. Similarly, in the denominator also R minus 1. Okay. Yeah. 1 minus R power of n, 1 minus R. If the R is greater than 1, R n minus 1, R minus 1. Okay. Another case, if R is equals to 1, if R is equals to 1, that is not considered as a geometric progression. That is the normal number pattern. If R is equals to 1, okay, for first term, I'll write first term as 3. Our second term should be 3 into R power of 1. So, 3 into 1, 3. Third term, 3 into R power of 2. That means 3 into 1 power of 2. 3 ones are 3. 3 into 1 power of 3. That one also 3. This is not a geometric progression. Okay, if R equals to 1, that is not considered as a geometric progression. In other cases, if R is less than equals to 1, we can use this formula to get our answer. If R is greater than 1, we can use this formula to get our answer for the sum of geometric progressions. Sum of geometric progression. That's all for this explanation. Okay, just try to note down these two formulas. We will do some questions. In this number pattern, we are going to find sum of 6 values. Okay, sum of 6 values, sum of 6 terms in this geometric progression. Before doing that, we need to find first term. We know the first term directly, no? First term A equals to 2. But we have to find the common ratio. To find our common ratio, from 6, I can divide 2. That is 3. Okay, that is 3. Yeah, if the common ratio is greater than 1, we have to use this formula as n equals to A into R to the power of n minus 1 upon R minus 1. This is the case. N is greater than 1. So, in this case, we have to use this formula. Okay. When you use this formula, our A is 2 into R 3. 3 to the, here we have to find 6 terms. So, 3 to the power of 6 minus 1 upon 3 minus 1. 3 minus 1. Okay. Then, we have to do furthermore calculations. Okay. For that, the thing, what do we need to do is, I'll write here. Okay. 2 into 3 to the power of 6. 3 to the power of 6 means 3, 3, 3. 3, 3, 3. Yeah. So, it is 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243, 243 3s are 729. Okay. 729 minus 1 upon 3 minus 1 means it's 2. 3 minus 1 means it's 2. So we can simplify this 2 and this 2. That will give you 729 minus 1. It's 728. 728. This is the sum of 6 terms in this geometric progression. First of all, if they were not indicated the common ratio, we have to find the common ratio. Then in the formula, you have to select the suitable formula. Okay, there are two formulas now. In here, n is greater than 1. So, is then a into r to the power of n minus 1 upon r minus 1. In this formula, you can substitute a and r values to get S6. S6 as 728. 728. That is the answer for this question. Yeah. Let's see. Okay. Okay, in here, first term that is directly to common ratio. That is 8 divided by 2, 4. We have to find sum of 5 terms, S5. So that is, here R is greater than 1. We have to use S5, A into R to the power of n minus 1 upon R minus 1. Okay, our A is 2, R to the power of 4, 4 power 5 minus 1 upon 4 minus 1. Yeah. 2, 4 power of 5 means 0.4, 16, 64, 64 fours are 256, 256 fours are 1012, 1000. 256, 1024. Sorry. It's 1024. Minus 1 upon 4 minus 1, it's 3. Okay. Yeah, 2 into 1023 is 1023 upon 3. When you divide this, it is 3, 3, 3, 3, 3, and another 8. 3, 3, 3 and another 8. 341. Okay. 341 into 2, it's 682. Yeah, your answer should be 682. Sum of 5 terms 682. Yes. Abiru, your answer is correct. This question is 7. We have to find 7 terms sum. A equals to 3 and the R equals to negative 6 divided by 3, that is negative 2. So, S7, here our R is less than 1. So, the formula which we have to use is S7 A into 1 minus R to the power of n upon 1 minus R. Okay, A is 3, 1 minus 2 power of 6, minus 2 power of 6 upon 1 minus 2. Okay, 1 minus 2. There's a negative 2, okay? Negative and minus 2. I'm confused with it. Okay, when I simplify this, 3, 1 minus negative 2 power of 6. Negative 2 power of 6, that is when you multiply negative 2 into 6 times, that is going to be 64. Positive 64. Positive 64. So it's positive 64 upon 1 minus 2 means 1 minus into minus plus 2. Plus 2. So 3. Oh, sorry. It's power 7. No. Sorry. My mistake. Power of 7. When I made any mistake, just tell me. Okay, it's negative 2. So it should be negative 128. Negative 128. So negative into negative, it's positive 128. I'll write the remaining here. 3 into 129 upon 3. We can simplify this 3 and this 3. So your answer for S7. S7 equals to 129. 129. S7 equals to 129. Okay, all of you found this answer correctly. Very good. Okay, finally we will do one more question. I will explain that question. Okay, here 2, 4, 8, something like this. Here Sn equals to 2046. 2046. We have to find n here. We have to find n here. Okay, while I'm doing, if you know how to do this question, just do this question with me. First of all, a equals to 2, and secondly r equals to 4 divided by 2, that is 2. Here our r is greater than 1. So the formula which we have to use is n equals to n into r to the power of n minus 1 upon r minus 1. n, sorry, this is a, 2 and r 2 power of n minus 1 upon 2 minus 1. Yes. Then Sn equals to 2046. 2046, that is equals to 2 into 2 to the power n minus 1. 2 to the power n minus 1. In the denominator, 2 minus 1, it's 1. 2 minus 1, it's 1. So we can write it like this. Okay, then after, furthermore, what do we need to do is, you have to take this number as a division here. 2046 divided by 2, that is 2 to the power of n minus 1. Okay, when we divide this, that is, I'll write the remaining here. It's 1023 equals to 2 to the power of n minus 1. I'll take this negative here, okay? That will become positive. So 1024 equals to 2 to the power of n. 2 to the power of n. So which power is 1024? Let's check. 2 to the power of 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Okay, which term? Mostly it's 10th term, 10th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So 2 to the power of 10 equals to 2 to the power of n. So n equals to 10. N equals to 10. So that means sum of 10 terms, sum of first 10 terms equals to, sum of 10 terms equals to 2046 in this geometric progression. N equals to 10. How I found this a and r? First I found a and r, then r is greater than 1. I selected the particular correct formula. A into r to the power n minus 1 upon r minus 1. I substituted the particular value. Less than 2046, 2 into 2 n minus 1 upon 2 minus 1. The denominator, that's 1. 2. So we can keep it as it is. I'll divide this by this. Okay, I was divided this one. So that is 2046 divided by 2 equals to 2 to the power of n minus 1. Then this is 1023 plus 1, 1024. That is 2 to the power of 10. So sum of first 10 terms in this geometric progression equals to 2046. This is the way you have to do this question. You know the basics clearly. How to find the a and r. If the r is greater than 1, which formula you have to use to find your sum. Okay, likewise, we are clear with that. It's very easy to deal with this kind of questions. Okay, that's all.